My name is Laurent. I work as a software engineer at Docker. First, I would like to thank ClickHouse for the invite for me to come present to you things for you today. And the things that were shown, I'll cover each of them, except for one product that was not listed here. Actually, there's an extra product that was not listed there. Is that the Docker hardened images, which are image for secure runtime. But I will go over that with a demo. I would like to talk to you about a new feature that's been a long time coming, which is the ability to run container in a more composable way. Because when you think about Docker, you usually think Docker pull, you choose an image, you run that image, and that's your container. But what is an image? That's not as simple as you might think. There was a lot of discussions for some time at Docker, like what's a pull and stuff like that. So defining an image is not as straightforward as it may seem. But if we boil it down and maybe oversimplify it a bit, an image is these three components. First, we have the manifest, one or more, and that contains the metadata about the image. Then we have configuration that describes runtime configuration of the image. And the most important part, the last one, is the layered file system. And this when you do a Docker pull, you see a bunch of things going. Normally, these are the different layers being pulled. And that's what makes Docker so efficient. And that's the base of what makes Docker image lightweight and cacheable. That's one of the most powerful parts of the ecosystem is the layered file system. So when we look at an image, if we look behind the scene of how an OCI image is defined, normally that's how you would see it. You would see the first part there. That's the media type, which described this as a manifest. And then the second part, we have a descriptor that points to a configuration object, which I'm not going to cover here, but that will contain the configuration of the object. And the layers part. And usually layers is a bunch of tar zip files that are extracted on top of each other, and that creates the baseline, the start point for your container. Now, traditionally, people are used to think of container as a self-contained thing and an image is the entire thing. But there is no reason for that. A file system is a file system, and there's no reason that it has to be the entire file system, which means that we can create OCI image that contains part of a file system, and with the new ability to mount an image inside another, you can create a container from different parts. So this is something that was launched in the Docker Engine 28 as an experimental feature. And it's also available in Kubernetes as it's still feature gate, but it's going to be stable release very soon. Now it's a beta status in V123. And the implication of this are massive. So most of my talk is going to be demos of what this kind of change can imply. So my first example is going to be the most the straightforward one, but it's a very common use case. Let's say in your organization you have certificates that you want to deploy, and all of your containers they need to talk to each other. The old way of doing this is to create a custom image for each one of your service that you have, just for the purpose of updating a certificate and injecting your own certificate. But why? We have had image mount for a while. Now we have OCI mount. So you can store your certificates in your registry and then mount them at runtime. You never have to rebuild your base image. So now I'll open. Most of my examples are going to be using Compose because that's the simplest way to show it.
Can you zoom in?
Yes, for sure. The main part is this here. Mount type image. The source is the name of your image you want to mount, and then the target where you want to mount it. And then for this, I have a little build tool. I have my certificates here in my search folder. And I have a little build tool that will merge a certificate with a base OS, in this case, Debian. So if I just run this, it's going to create a certificate and push it to registry. Now, if I do a compose up, I have my Nginx service here and a client, which is a base Alpine, that just does a query using the certificate. I'm using the same volume mount, the same image mount for both for the certificate. So if I do docker compose up, you can see that my service talk to each other with my custom certificate. No need for a new image, no need for a custom image. There you go. Our Nginx started, and now our Alpine did the wget command. So now our containers are communicating with the custom certificate without modifying the image. The second one is also a very common use case where in many roles I've had before Docker, it is always a challenge to have testing data in a database. Either you have some script that takes a minute or so every test to spawn out, and then they're never quite accurate. It's kind of difficult to share between the team. Now, you can create image that contains database state, and push this to your registry, and share it between your team. And that means that your container spawns up instantly. There's no more delay. So if I go to my second example, and then this example, another thing too, is that it highlights one of the current limitation of this feature that we're going to remove in the future. Right now, image mount only supports read-only file system. So to get around this, we simply do an init container. We provide an empty volume, and then we with the image mount, and we copy the content of the image into the new empty volume, and then we spawn the database after this. So this is just an init container with our busybox, an empty volume, and then our image. In this case, I have some sample database in Postgres 17. That is the AdventureWorks sample database. And then in my Postgres, I have my depends on. And when the init service completes successfully, then it launched with the new initialized data. If I do docker compose up, boom. Now we have our client that did the query of the data. And the implications of this are pretty big, because now what it means is you can create data sets for your database that are much bigger than your typical test data. If you want to do test or load testing, you can create as big as a data set without having to wait for this data to be provisioned. Another use case that we've heard a lot is the test data does not mimic adequately production database. Now there's a service where you can use synthetic data that will create fake data based on your existing data without having the risk of being able to reverse engineering and remove the de-anonymization effort. So now you can have a lot better data for your tests, and you can share this because now you can just push to a registry. And this can be version control, not version, but it can be tagged and it can be evolved over time. The example I'm most excited though is the ability to debug hardened containers. Like I said in the beginning of the talk, we just launched our Docker hardened image catalogs. So these are slimmed down image for security. What this means though is that we've removed all utility tools that are not essential for running the containers. And the complaint from all the competitors in this area is that by removing these tools, you make them very difficult to debug. But you don't have to choose that. With image mount, you can mount the tools only when you need to, only for debugging. Some languages are better than others, and I'm going to demo Go. I have two examples using Go. One is very simple, just to illustrate the easiest way. I have an image which is the Delve Go debugger here with iMount. And I run the Delve debugger, listen to itself on port 2, 3, 4, 5, and I run my application here. And then my application is just this main Go. I have my breakpoint here. And then because I'm using VS Code, I have my launch JSON here, or I can go to the debug and the setting here. And you'll see that I have this configuration here, which I'm attaching to a remote Go session. This is what this block means here. Oh, I don't want to do that. On the port, the host itself. And what I'm doing is I'm substituting the path to my local source to the source of the Go compiled. So that kind of matters, this Go source here. So if I run my minimum Go, I'll show the build, the Docker file. The Docker file is I build my Go, but I'm copying in on an empty container. There's nothing else. There's just a Go binary. So if I go and then Docker compose up. Now the container is running. It is waiting for a debugger session. I'm going to run this, and I hit my breakpoint. So now I'm debugging a Go application deep inside a container. And this also works in Kubernetes. If you have Kubernetes and you do port forward, you can debug deep inside your Kubernetes infrastructure. Now I'm going to show a bit more real-life example. We have, for example, here, this is our DHI. This are Docker hardened images. So this is our external DNS, which is a Kubernetes-based container. And again, we're mounting the DHI Go debugger. Same syntax of the command. And again, in my debug JSON, I'm just mapping the external DNS to a different source. And this is the point. And then I have my external DNS source here. And in my main.go, I have a breakpoint. So if I go same thing, it's waiting for connection. I'm going to run this again. And now I'm debugging hardened images without having to modify the image. We're just injecting at runtime the tools that we need and only for this session. Now, I know this is an AI meetup. You're probably more excited about the AI stuff. I'm getting to this. AI is still very relevant to this problem because of the size of the AI models. And the AI ecosystem is very fragmented. There's different ways to run a model. So having a tight coupling between a model and the runtime just doesn't make sense. It's unsustainable. It's difficult. It makes a lot more sense to have models stored in the OCI and have the runtime completely separate. So I have an example here of this. I created a test OCI layout that contains the BERT model. And then we see here, I'm mounting the image, which is the BERT model. It's in the path that it's expecting. I can compose up. So now I have this. We have the runner running, and I'm going to exec in. Exec to IT, and then it is BERT run. Okay, so I just came back from New York City, the Big Apple. And then I want to show what is New York City called. The Big Apple. So this is, this features really allow us to look at how we run containers in a different way and have logical parts. And then my favorite example regarding AI is when it comes to RAG. I don't know if you're familiar with RAG, but the practice of augmenting AI result with your own custom data. And interestingly enough, RAG has the same challenges and opportunity as a database, but in a slightly unique way. Again, you're having to ingest your vectors into a vector database at runtime is very time consuming. We can have the same benefit as a database of loading or mounting an image that contains all your data pre-populated. And then it's actually better than a database because the data in RAG is it doesn't evolve over time. You can have experiment, you can change, you can tweak the data and constantly have different version, and you can share with your team. In fact, there might be different teams. You can have a team building the vectors and another team using those vectors. So now you can use OCI image to share those states, share those experiments across your team. So in here, I have a quadrant database, which is one of the popular ways of storing vectors. And I'm using the same workaround as the database before. I have an init container, a busy box, where I'm copying my vectors data into an empty volume. I'm embedding here, and this is the name of my image. Okay, so now my quadrant is running. It has some pre-populated data. Now I'm going to sprinkle in the magic. My colleague had mentioned earlier, now we have the Docker AI model, the Docker AI runner. I'm going to use this AI runner to generate vectors to use with Quadrant. So before, I'm going to go in my Docker settings. I'm going to make sure that my AI model runner is enabled, and I'm going to make sure that my host side TCP support is enabled. And that's going to allow me to send REST queries to do more advanced stuff. In this case, I want to get embeddings using an AI model that I got versus Docker model pull. I'm not going to do it here because the model is huge. We don't have time for this. So now I'm just going to query the model runner, run it through JQ, and just get the embedding out of the payload that I get. And then we have the vectors that we can use. And just to show that it works, I'm going to scroll. Oh, all right, the buffer. I'm going to scroll. And get this data. And then we're going to open our Quadrant UI. We see that we already have our data populated. That was instant. And then we're going to go to the console. And we're going to query instead of null. We're going to put our vectors here, scroll, and then run. And now we have a list of documents that matches or that are similar to the query that I just ran. So in conclusion, this is like a fundamental tool. It's a foundation tool. It allows you to change the way you look at containers, and it allows you to change the way that you work and work more effectively, more efficiently, and more importantly, allows you to work better with your teammates because now you have registry at the tip of your finger. And as a senior engineer, that's really powerful. I can have all these tools ready in a registry, and when a new member of the team, everything is ready for them. It's just Docker pull. And that's it. I hope you like this demo.